Okay, so next up we're going to go ahead and we are going to go through each of the practice problems for the descriptive statistics. So just make sure you go ahead and have your copy of RStudio open if you don't already. And we're just going to go ahead and run through these pretty quickly. So again, what you're going to want to do is you're going to want to load the data that we had previously. So again, if you have the data set open already, the one easy way to get these data to open is to just go ahead and import the data directly using and by just clicking on it. But again, if you want to have a easier and faster way of doing it rather than having to point and click every single time, then we can just go ahead and we can load them with code. So I'm just going to go ahead and I'm going to load in some code lines that I've already used throughout this course. But just one more time as a reminder, if you need to go ahead and get to the folder that you're trying to get to for these code, you would just go ahead and you're going to copy the path name in to your data set. So we would just go ahead to the set working directory and we're going to copy that in and use that little squiggly line right there at the front. So let's just go ahead and we'll run those code and then we should be able to run those data directly. Okay, so now that our data are loaded, let's just go ahead and let's go through the data set in detail in terms of those practice questions. So first question is calculate the mean, median, standard deviation, skew, and kurtosis for BMI in each group. So again, let's just assume that we're doing this at baseline. So in order to do that, we would just go ahead and we're just going to subset the data for data 2 and then time equals 1. Okay. And so now we can just go ahead and we can use the describe by function. And for that, we'll just go ahead and go to baseline, BMI, and then baseline group. And then that's going to give us the mean, standard deviation, median, skew, and kurtosis for BMI for each group. Now, what is the proportion for the full sample? Well, the easy way to do that is, again, we can use that describe function, and then we can just do baseline, BMI. And then that will provide us with the mean for the full sample. But again, if we want to try and have it a little bit neater in terms of what we want to get from this, we'll just use that describe by function again, baseline, BMI. And as you can see, we now get the mean, standard deviation, and all that jazz for for all participants. Okay, next up, question number 2. What is the proportion of people with a high school education or less in the intervention group? Okay, so the first thing that we have to do is we're just going to go ahead and we're going to make some categories for education. I'm just going to do this pretty quickly. So just as a reminder, we would go ahead and we are going to revise that education variable into a categorical variable that's no longer numeric. So we're taking that education variable and those numbers 1, 2, and 3, and we are revising them into categorical numbers that are characters. So high school or less, trade school, and university. Once we've done that, we can go ahead and we can use the table function. And from here, we're just going to go ahead and call education again. And then we're just going to go ahead and we're going to get group. And then that's going to tell us how many people in each group have a high school education or less, a trade school education, or a university education. Then if we would like, we could also do this as well. If we were so inclined for doing this, we could do this with by using the table 1 feature. I'm not going to go through that right now. But what we can do is, just as a reminder, is to answer that question, how many people have a high school education or less in the intervention group. We can look through, and we have 8 individuals who have a high school education or less. And again, if we wanted to go through that same business of trying to get to this point using the Create Table 1 feature, I'm just going to go ahead and I'm going to load some code and we'll just talk through it really briefly. We would call the variable names from baseline that are equivalent to our continuous variables, and then our categorical variables right here we could call as 5 and 6. So just to make that a little bit more clear, we're just going to load those baseline data in terms of the column names. 4, 9, and 10. So 1, 2, 3, 4. So that's 4 is age. Then 9 is BMI, 10 is ADAS-Cog, and then 11 is meters walked. And then the categorical variables of 5 and 6. So this is 5, sex, and then 6 is education. And we would have separate tables for those. So again, if we load table 1, so we have to first load that table 1 feature. Once we do that, let's make sure that that is loaded. And then as you can see, we can get nice baseline statistics for by group for each of our continuous variables. And then for our categorical variables, we can get that separately as well. Now, if you notice, sex is being treated as a continuous variable right now, and that's because it's loaded as 1, 0, rather than as something that is a character in nature. But for education, we can see that this is a categorical character, and so we get to the same point where we see that there are 8 individuals in the intervention group have a high school education or less. Okay, moving on to question number 3. So for this, question number 3 asks, what is the proportion of people with a university degree in the full sample? And we'll just go ahead and we can answer that really quickly since we've already done this in table 1. And we can see that there are going to be 7 plus 5. So there should be 12 individuals in the full sample. But if you wanted to just make sure about that, we could just run a table and we could just go ahead and use baseline and education for the full sample, and we would be able to get to that same point. Now, if you notice before, I have in table 1, I have this stratified by group, but if I don't want it, if I don't want to stratify by group, then I would be able to get to the same point. So I will go ahead and run that, and as you can see here, there are 12 individuals who have a education of university or higher. So 12 here, 12 here. So we get to the same point either way. Okay, next. How many women have a university degree in the full sample? And how many women have a university degree in the control group? So let's just get that question up. So how many women, sex equals 0, have a university degree in the full sample? And how many women have a university degree in the control group? So once again, we can just create a table, the easy way to do this, and then sex, and then baseline education. And so this is going to be stratified into 0 and 1. And again, let's assume that 0 is women, 1 is men. And from here, what we can see is that there are 6 women in the full sample. What we can see is that among women who have a university degree or higher, if there are 6 women in the universe who have a university degree or higher overall. Now let's see how many people in the control group are women who have a university degree or higher. Well, to do this, we can just create another table and just make it a little bit more complex. So again, we're just going to go ahead. We're going to go ahead and run table again. Same command overall. Now we're going to add a third line where we are going to call baseline group, and then we're just going to call that con. And what we can see is we're going to see different, it's going to be different for the false command and for the true command. So for the false command, that means that if con is not true. For the true command, that is if con is true. And so what we can see here is that if con is true, then it appears that there are, excuse me, um, sorry, I ran that command incorrectly. So if we run it with con equals true, then we can look at education again. And so con is true. And so let's just look for number of women in the control group who have a university degree, and the answer is 4. So we have 4 women in the university who in the control group who have a university degree or higher. Okay, question number 5. What is the average ADAS-Cog score for women in the full sample, and what is the average ADAS-Cog score for the men? So again, we can use that baseline describe by command, and then we're just going to use baseline ADAS-Cog baseline sex in order to be able to find the average ADAS-Cog plus score for women in the full sample, and then as in comparison to men. So again, if women equals 0 in these data, then we can see that the average score for women is 9.3, whereas for men it's 13.43. All right, next up. Let's just run through this next one. What is the average ADAS-Cog score for men in the intervention group in comparison to women in the intervention group? So what we can do is we'll just run the same command again, and we will go ahead and let's just do describe by. And we're just going to do baseline or excuse me, what we can do in this instance is we can subset into 2 separate groups. So let's just go ahead and we're going to subset our data into the control group and the intervention group. So in this case, we're just going to do baseline for con, and then we're going to have a separate one called intervention, and this one again subset at baseline group equals int. Okay, so we now have our 2 different data sets, one for the control group at baseline, one for the intervention group at baseline. Now we can run that describe by function, and then we're just going to run intervention. Let's make sure it's spelled correctly. ADAS-Cog, and then intervention by sex. And so this will create, if you run it, if you put in the right names for your data, this will create a estimate of the average ADAS-Cog score for men in the intervention group. So in this case, we can look at where males equal 1. We can see that the intervention group had a score of 16.47 on average for males, and a score of 8.96 for females in the intervention group. For women in the control group, we're just going to go ahead and we're going to run a similar command, this time calling from the control data set, and this time again we're going to look for the ADAS-Cog plus, and then again by sex, and we should be able to figure out from here that sex equals 0. So for women it's 0, and then their mean would be 9.77. So for females in the control group, their score is going to be 9.77 at baseline. Okay, we have one more question left for these data, and that's going to be use the table 1 package to create a table with the following variables: 6-minute walk test, age, ADAS-Cog, and weight. So in order to do that, we're going to again use that var. We're going to create those a data set of those variables. So we're just going to call it vars, and then again it's going to be if we just look at the column names, and you can just type in column names and then call the data set of interest, and again we're just going to find the columns that we're looking for. So again, age is column number 4, in the correct order. So in this case, we're going to make sure these are all in the right order. So let's do 6-minute walk test first. So that would be 9, 10, 11. So it would be 11. And then age, which is 4. And then 8 as cog, which is 10. And then weight, which is 8. And so we have those 4 columns. So meters walked, age, 8 as cog, and then weight. And then from here, we're just going to use that table 1 that we're going to conduct. We don't need to put in stratification for right now unless you want to. And then from here, we're just going to run that table 1 command, and then that's going to create our table that we're looking for in terms of meters walked, age, 8 as cog, and then weight. Okay, so with that being said, we're going to move on next to doing some basic inferential statistics in R, such as correlation, linear regression, and then ANOVA.